For number 1, it says state the domain and range of the function given by 1, -4, and, well, I'm just going to tell you all the rest of those points. So anyway, when they ask for the domain and range, they're talking about the x values and the y values. Domain is the x values. So we see all the x values, and we need to list those in order inside some squiggly brackets. So we do it from the least to the greatest. That gives us 1, 2, 5, 8, and 11. That's the domain because that's all the x values. Now the range is all the y values. So we look through and we see all the y values, and we need to list those in order. So the smallest is -4, then -3, then 0. Then you notice there are 2 8s. So just list that one time. If a number shows up twice, you still only list it one time in the domain or the range. So then it says, is it a function? When you're considering if points put together are a function, you just look at the x values. That's all that matters, is the x values. If all the x values are unique, then yes, it is a function. So as you look at this one, 5 points, 5 different x values, so yes, it is a function. Again, you look at the x values, as long as none of them repeat, it is a function. If any of the x values do repeat or show up more than once, then it is not a function. Y values don't matter. They can repeat every time, they can repeat not at all. It doesn't matter as far as whether it's a function or not. Okay, for this next one, we're saying which of the following is a function. We're looking at a graph. To do that, just think the vertical line test. So right here we see this is not a function because the vertical line does hit it in more than one point. So it is not a function. For this one, it is a function. As I pass it through, it never hits the line at more than one point at a time. So B is the answer because B is a function. You can see part C also hits the vertical line in 2 parts, so that's why it is not a function, because it fails the vertical line test. Now in number 3 it says find g of 5 if g of x is equal to x squared minus 9x plus 4. So what that's telling us to do is plug 5 in for x. If you look at it, it's almost like we're just substituting. We did have x in there, now they want us to put 5 in there. So we put 5 in for x. We get 25 minus 45 plus 4. So when you compute all that, you should get -16. Number 4, state the domain of the equation. When you're looking for domain, at least for our purposes, you mainly need to watch out for 2 things. One of them is that you cannot equal 0 in the denominator. There's another one we'll talk about in number 5, but we got to make sure the denominator does not equal 0. So I'm going to set the denominator not equal to 0, because it can be anything else, it just cannot equal 0. We're going to need to factor this one to find out where it does not equal 0, or where it would equal 0, so we can cancel that out. So things that are multiplied to be 12, add up to 4, we get plus 6 and minus 2. So for this one, as we set each of those equal to 0, we would get that x cannot equal -6, and x cannot equal +2. So x cannot equal those 2 numbers because those 2 numbers make the denominator 0. Part B is the same. We take the denominator and set it not equal to 0 because denominators cannot equal 0, and then solve for x. So for this one we get x does not equal 5/2, or you can say x is not equal 2.5 if you prefer. Like I said, there's 2 things to consider, and as we look at number 5, we see the other one. So first of all, we cannot have 0 in the denominator. Second, we cannot have a negative inside of a radical. Well, inside of an even one. So square root, 4th root, 6th root cannot have a negative inside it. So that means we need 6x plus 5 to be greater than or equal to 0. Because it can't be less than 0, because that would make it negative. But it can be greater than or equal to 0. Square root of 0 is fine. So I subtract 5 from both sides and divide both sides by 6. So I get that x, in order for this to work as a function, has to be greater than or equal to negative 5 over 6. Now for part B, we have both issues happening to us at the same time. We know x plus 1 can't be negative because it's inside of a square root, but it also cannot be 0 because it's in a radical. So this time we just do x is greater than 0. So here's the big picture. You set denominators not equal to 0. You set radicals greater than or equal to 0. You set radicals in the denominator greater than 0. Again, we can't be negative because it's a radical. Can't equal 0 because it's in the denominator. So we just solve that for x, and we get that x is greater than negative 1. Number 6 is what is called a composite function. It's when we're putting two functions together. It gives us f of x, x squared plus 3x, and g of x, the square root of x plus 3, and says find f of g of x. What it's telling us to do is take the g of x, the one that's on the inside, and plug it into the other function. So we're going to plug g of x into f of x. So I'll take g of x, square root of x plus 3, and plug it into the other function. Now notice there are two x values. I need to plug it into both of them. If there's only one, you just plug it in once. But however many x values there are, you need to plug it in that many times. So I plug it in for all the x values I see. I put square root of x plus 3 squared plus 3 times the square root of x plus 3. So I can simplify that first piece. The squared cancels out the square root, leaving me x plus 3. And the next one really can't be simplified, so we'll just leave it as it is. 3 times the square root of x plus 3. For number 7, it says find the equation of the line with m equals 5/4. That means the slope is 5/4 that passes through the point negative 1, 7. When you're writing the equation of lines, you really need a point and a slope, and this gave us exactly that. So I would use the point and slope formula. It's okay if you use y equals mx plus b, that's fine. It's your call. And I do y minus the y value, which is 7, equals m, which is the slope, 5/4, x minus the x value, minus a negative 1 is plus 1. So then I just have to simplify and solve for y. If I distribute the 5/4, I get 5/4 x plus 5/4. Then I just add this 7 to both sides. And you're welcome to use decimals if you prefer. So this will be 5/4 plus 33 over 4 or 8.25. Either way is fine as far as the way you write it. Now number 8 says circle the relations that are also functions. And there may be more than one. So there could be three of one and one of the other, or 2 of each, or any combinations possible for this one. So when it comes to functions and equations, you basically have 3 things that make it not a function as far as we're concerned. First, if y has an even exponent. If y has an even exponent, then it's not a function. Or if y is inside absolute value, then it's not a function. Or if there's no y at all, then it's not a function. So these 3 things tell us, no, it's not a function. So as I look at A, I know it's not a function because we have a 3y squared. So because of that, this is not a function. Y has an even exponent. B, we have y inside absolute value. So it is not a function either. C does not have a y value. It's a vertical line itself, so that's not a function. D, however, is a function. Y does have an exponent, but that's okay as long as that exponent is odd. We just can't have it with an even exponent. So D is a function. For number 9, we're again trying to write the equation of a line. So to do that, we need a point and we need a slope. Well, we're given a point, right there. And we're given information to help us find the slope. We are going to have to find it. We're told it is parallel to this line right here. Parallel means they have the same slope. So I'll need to figure out what the slope of this one is. So I'm going to first subtract 5x from both sides, and then divide both sides by -2. So I get a positive 5 halves x minus 9 halves. But all I care about is this right here, because since they are parallel, that means they have the same slope. So since this one has a slope of 5 halves, this one has a slope of 5 halves. So we have a point now, 1, 3, and a slope, 5 halves. So I do y minus 3 equals 5 halves times x minus 1. Then I just simplify and solve for y. I get 5 halves x minus 5 halves by distributing the 5 halves. Then I add 3 to both sides, and I get my final answer, which is y equals 5 halves x plus 1 half, I believe. I'm going to double check that in the calculator. I think that's right. Negative 5 halves plus 3. Yep, plus 1 half. Okay, next one. Write the equation of a line that passes through 1, -5 and is perpendicular to the line 7 halves times x plus 1. Okay, again, we need a point, we need a slope. A point, we're covered. We'll have to use this information to find the slope. Perpendicular means it is the opposite reciprocal, meaning once we find the slope, which we see right here is 7 halves, the slope of our line is the opposite, meaning negative instead of positive, and the reciprocal, meaning we flip it over. So perpendicular slopes are opposite reciprocal, meaning flip them and change the sign. So then I have y minus -5, so that's plus 5, equals -2/7 times x minus 1. Then I just simplify to get y by itself. Distribute the -2/7 and subtract 5 from both sides. So your final answer is y equals -2/7 x minus 33/7. For number 11, we're starting to talk more statistical kind of stuff, or things we'll be putting in the stat part of our calculator. It says the chart below shows the number of touchdowns accumulated by Eli Manning each year since 2004. Use the data to answer the following questions. So please note this is years since 2004. So 1 means 2005, 2 means 2006, and so on. And it is cumulative touchdowns, just so it makes sense. He didn't score 125 touchdowns that 1 year in the 5th year. He had just totaled that over the period of all 5 years put together. So it asks us to plug the data into the calculator and run a linear regression. So here's what we do. I'll make sure you know how to get there. When you're in your normal window, just click Stat and then Edit. Put all the X values or the top row in L1. Put all the Y values or the bottom row in this case in L2. So that is already plugged in the calculator for us. You would need to type it in L1 and L2 and then run a linear regression. So I go to Stat, Calc, for Linear Regression, and I am going to store this equation in Y1. Now the way I do that is I go to vars, yvars, function, Y1. That'll automatically graph this for me so I don't have to retype it. Okay, so there's the equation. The A and the B are what I need. So the A, that's the slope, is 26.023. And then the B, the y-intercept, is -0.107. So that's our linear regression equation. Alright, now let's move on to number 12. It says, what is the slope of the line? So going back here again, the slope of the line is this number right here, the number with x. So it's 26.023. What does it mean in terms of this problem? Slope is the amount of increase in y, which is cumulative touchdowns, per x, in this case years. So that's true in general. Slope is the amount of change in y per x. So in this case, it's the amount of touchdowns on average he tended to score per year. So the number of touchdowns he tended to score, or scored on average, something like that, per year. What is the y-intercept of the line? So the y-intercept is the number by itself, negative 0.107. So negative 0.107 is the y-intercept. What does it mean in terms of this problem? In general, the y-intercept tells you how much y you have when x is equal to 0. So let's go back and look at this for a minute. When x is equal to 0, that means we're in 2004. If we're 0 years since 2004, we're in 2004. So that's the amount of touchdowns he had in 2004, which means we're pretty good because it's close to 0. So this is the number of touchdowns, or the amount of touchdowns he had in 2004. So again, in general, the y-intercept is the amount of y when x equals 0. And then it says, what is the correlation coefficient for this data? So I want you to look at the r squared. So the r squared here, you can see it in the calculator. You need to make sure this is turned on. Just so you know how to do that, go to Mode, go down to the second page, and where it says Stack Diagnostics right here, make sure that is turned on. So let's make sure we see it. Our r squared is 0.996. 0 should be there. There we go. 0.996 is our r squared. So does this imply a strong or weak correlation? This implies a strong correlation. Anything above 0.9, you want to get as close to 1 as you can. So anything above 0.9 is strong. Number 15, use your line of best fit, your answer in part A, to predict the number of touchdowns that Eli will have accumulated in 2014. So remember, the years are the x values, so we need to plug something in the x value. Since the x values, let's go back there, are years since 2004, then the year 2014 would be 10 years after that. So I need to plug in 10 for the value of x. Now you can do that manually by hand. Go back to the equation, plug in 10. Or, since I automatically plugged mine into y equals, you don't need this one, sorry, it's there. You can go to the table and just type in 10, and it plugs it in for you. So it's about 260 touchdowns that he'll have accumulated, we predict, by 2014. Now in 16, we're talking about piecewise functions. It says use the following piecewise function to find the given values. So first it asks for f of negative 3. Now we need to look at this part over here, these two. These tell us where we plug it in. Negative 3 is less than negative 1, so that means negative 3 should go in the top equation. So we do 4 times negative 3 plus 1, which is negative 11. For part B, we're supposed to plug in negative 1. So we use the top one again because this is where x is less than or equal to negative 1. So I plug negative 1 in there. And that should give me negative 3. Now for C, we have f of 2. 2 is greater than negative 1. So that means it goes with the second one. So we plug it into the second equation, or the bottom equation. Plug in 2 squared minus 5, so that's 4 minus 5, that's negative 1. And for the last one, 5 is also greater than negative 1, so that means we plug it in the second, or the bottom equation. We put 5 squared minus 5, and our answer is 20.